This is question 18 of the exponentials and log functions assignment. This is a word problem or semi-real world problem. The salvage value S in dollars of a company jet after T years is estimated to be given by the formula below. Use the formula to answer the questions. So our salvage value S at T equals 500,000 times 0.9 to the T power. So this is an exponential with a base less than 1. So as time goes on, the value is going to decrease. Now this says what is the rate of depreciation in dollars per year after 1 year. So here we don't want to evaluate the value, we want to evaluate the rate of change, which is a derivative. And this is an exponential with a base other than e, so we have to use the formula. So we're going to use this formula. If y equals b to the x, y prime equals the natural log of the base times base to the x power, the original function. Now here we have a constant multiple of 500,000. So s prime at t is going to equal 500,000 times the natural log of 0.9 times 0.9 to the t power. So I'm going to go ahead and put that into the calculator and evaluate it for 1, and they're going to have us do other values as well. So I'm going to call this S prime at t. So what I've got here, no variables, so S, P, R, I, M, and then at the variable t, get out of that little parentheses, then control palette of math. I'm going to enlarge this a little bit. So there's a colon equal sign. That means is defined as. So this function is defined as 500, 1, 2, 3. I want natural log, which I get by hitting control e to the x, 0.9, and then times 0.9 to the t power, but we're just going to make that a 1. Or actually, we'll put in t. We want the variable here. So we're going to hit enter, and it says done. And if we go to var s prime and we put in t, well, it changed it quite a bit. And that's because we put in decimals here. But this is still going to be the correct answer, so I'm going to go put in 1 for t, and it will be that same number. Or no, it's not. Okay, so that's my rate of change. So it's negative 47,000 and change. So we're going to go put that answer in. So negative 47412. 47412, then 0.23. So the value of the jet is going down by 47,000 and a little bit more per year. So we'll check that answer. Well done. Okay, so we're going to hit OK and go on to the next one. What is the rate of depreciation in dollars per year after 5 years? So we're going to go to S prime at 5. Enter, and I get negative 31,107.17. So negative 3111 or 107. Too many ones. So 31107.17, rounding to the nearest penny or cent. Check answer, good job. Now after 10 years, so S prime at 10, and we get negative 18,000. Negative 18,368.47. Check answer. And before going into the next question, I'm going to show you a couple things in the calculator. I could put in this salvage value function. So we'll go S at T, and then we want to go control palette of math, so that's is defined as, and we'll put in the function 500, 1, 2, 3, then we can put in parentheses 0.9 to the power of t. We'll hit enter and it says it's done. So now we have S and S prime. So if we go S prime at t, it looks just like we put it in. Now I can take the derivative of S at t. Shift minus t is now our variable. Tab to move through the template. Then S at t. And whoa, that looks way different. So the reason this looks way different is because I've got a decimal point in here. So this did the multiplication of 500,000 times the natural log of 0.9. So if I don't want that strange decimal looking thing there, I can do this. I can go to S2 at t, control palette of math to get that such that symbol, and I'm going to put this in as 500, 1, 2, 3, then times, instead of 0.9, I'm going to do the fraction 9/10, and then get outside here and that to the power of t. It's the same thing, but I didn't use any decimal points. So it says done. Now we're going to take the derivative of S2 at t. So S2 at t. And here we get what we were looking for. 500,000 times the natural log of 9/10 times 9/10 to the t power. And we'll go ahead and evaluate that for t equals 10 and see if we get the same answer. So actually I don't want to do that. That's the original function. So I need to evaluate this expression at t equals 10. And now I'm going to put in a decimal because I do want the decimal answer. And we get the 18,368.47. So that concludes this video.